welcome back to Tech Tips, Fixes and More. My name is Ron and welcome back. It's been a little while since I put out a video, but I'm happy to be back and recently got in a heavy duty and heavy in weight commercial power amp. Now this amp was being used at a church camp, and recently there were some weather events that involved quite a bit of lightning, and we suspect that there was probably a power surge that has damaged this amp, because it was working, and a few days later after this big storm, when we turned it on, or tried to turn it on, it popped this breaker on the front as soon as we powered it up. So that makes me suspect that there's a catastrophic problem with probably the output transistors in this thing. So I went online and went looking for a schematic. I did find a schematic. It wasn't very good. It was a scanned copy, and it was a little difficult to read some of the parts numbers and so on, but it gave the basic information. I also checked out YouTube to see if there were any videos on this particular amp, and I found one or two. They were not totally helpful, but they had some information that could be contributed to this. One of them had information on cross-references for the output transistors. This is a pretty old amp, and I think it probably was built back in the 90s. And so some of the output transistors are no longer available. So that you have to use a cross-reference. So if we need some of those, at least I have some clue of which direction to go with it. So we're going to have to try and power this up slowly, probably using a variac, and see if we can see what's going on. But even before I do that, I'll open up the lid off this and do a visual inspection to see if I see any burnt components or anything that's obvious, and hopefully we can get some clues as to which direction to go. And so let's get into it. As I said, this amp has been used out in a camp, and it's been there for a few years, and it's probably never been opened, so you can see that it's pretty grungy. Okay, so I took this out and blew it out. There was a lot of dirt in there, which isn't totally surprising considering where this thing was used. And who knows, maybe there was enough dirt to actually cause some problems with overheating or something. Anyways, I brought it back and plugged it in. I didn't get this on camera, but I thought, because the last time I had tried this, it had blown this breaker on the front, I thought I could at least try and plug it in, turn it on, and if it did that again, I knew I had a problem. And if it didn't, you know, maybe it actually had something to do with all this dust. But it surprised me, because when I turned it on, I actually got a snap, and I could also smell something burning. So I turned it off very quickly and just proceeded to take the sides and the top off and do some looking around to see if I could find anything burnt. And so far I haven't actually located anything that looks bad in terms of visually. So before I go on, it might be worthwhile to lay out some basic information about this amp and how it's set up. And so this is a power amp. It's got a front end section that takes a line level signal and amplifies it up to a level that can then be used to drive the power output section. It's also stereo amp, so there's actually two of all of that. And there's also a power amp section for each of those. I should also say that there's a power supply section, and sometimes the power supply is common to both sides and sometimes it's dual power supplies, one for each side of the amp. So I do have a schematic. It's not the best schematic because it's very unclear. It's a scanned schematic. And this particular schematic here is just for the input section. There's an A section and B section, and they each have a connector that drives out to the power amp sections, and here are the power amp sections. And the way they've numbered these things, the A side of the amp, all the numbers are 100 series components, and all the B side, they're 200 series components. Now in this amplifier, in the power amp sections, there are 16 power transistors. They're high current transistors in TO3 packages attached to a heatsink, and there are 8 of these transistors for each channel, 8 for channel A, 8 for channel B. Of those 8, each channel has 4 NPN transistors and 4 PNP transistors. This is a class AB amplifier, which means that it's what's called a push-pull amp. And so on one half of the waveform, the NPN transistors are conducting. On the other half of the waveform, the PNP transistors are conducting. So they alternate in sourcing the power. So what I ended up doing was starting with the power transistors and doing some diode checks using the diode function on my digital voltmeter. And for those of you who are not familiar with that kind of thing, basically what it does is it applies a constant current through the leads to forward bias semiconductor junctions. And if a junction, if a silicon junction is forward biased, it'll show somewhere between 0.5 and 0.7 volts when it's forward biased, and it'll show open circuit, or OL usually it displays, when it's reverse biased, because current can flow one direction through a diode or a rectifier, but not the other. And so a transistor basically is made up of 2 junctions, and the leads are base, collector, and emitter. So you can forward bias the base emitter junction and tell whether it's okay. And you can also forward bias the base to collector junction, and it should show you if it's okay. So I'm going to check the power transistors. So there we have 0.5 volts, so that indicates a good forward bias junction. If I move this over to the case, you get another one. So that transistor looks to be good. Now I'll go to the next one, and 4 of these in a row should be NPNs. Now that one is showing 0 volts forward biased, and that's 0.4, which is a little low for what it should be anyways. So that one looks like it could be shorted, either that or there's something else in the circuit that is shorting across that. Let's go to the next one. This one shows 0 and 0.4. This one shows 0, 0.4. So the first one in that line looks good. So after becoming a little bit more familiar with how the circuit was actually set up, I also measured the PNP transistors. Now all of these measurements were on the A side of the amp, and I realized that the PNP transistors were basically showing the same thing. The first of 4 transistors was measuring okay, and the other 3 were all measuring shorted. And so I looked more closely at the circuit, and I noticed a couple of things. First of all, the emitter resistors for all of those are very low values. They're 0.33 ohm resistors. And those 3 transistors were all connected in parallel, so you're basically doing the same reading when you did that test. So that was a little misleading, and eventually I had to pull out all of the transistors on this board and measure them on a circuit to find out. And what eventually happened was I found out there were only 2 transistors. They were in the B side of the power amplifier. One was an NPN and one was a PNP, and they were fully shorted. It was difficult to detect that until I was able to pull everything out. I had to desolder all of these transistors and take them out and then measure them individually. Mind you, that was not the sum total of the problem. There are many other problems in this, and I had to do additional troubleshooting to find those after the fact. What's kind of interesting about this is that those particular transistors failed. This is one of those weirdities related to a lightning strike. Certain components will be blown up and other ones will be fine, and I'm not sure how to explain why that happens, but I have noticed it before because I've worked in industrial situations where lightning had destroyed certain components, and there didn't seem to be any way of predicting which ones would be destroyed by lightning and the other ones would be okay. Okay, so I went ahead and just did a bunch of resistance measurements, and it's kind of a shotgun approach, and I found that several power resistors in this area were faulty. This one, this one, this one, and this one, they were 3.3 and 5.6 ohms. There are some triacs in the output here. I'm not exactly sure what those are for. They might be to some kind of a protection mechanism. But when I measure across one of them, I get an open circuit, and the other one I'm showing a short. So that is one of the nice things about working on a stereo amp. You can actually compare sides, and so there is something different there. I'm not going to make any predictions here, but I think it's worth taking that component out and checking it. Yeah, it looks like that is shorted. So now we have 8 resistors, 1 triac, 2 transistors. I went looking, and if I were to go and order the bare minimum of parts that I would need, it would probably cost close to $100. So I talked to the customer, and the customer really isn't sure that he wants to fix this amp. It is pretty old, and also because I couldn't guarantee him that even if I replaced the faulty parts that this would solve the ultimate problem. Because if this truly is a lightning strike, anything could be blown up in this circuit, and there's just no way of knowing until we test it out completely. So the customer has decided not to go ahead with fixing this, and they've given me the amp and just said do whatever you want with it. So I may revisit this in a little while and still order these parts and just see what I can do. But there's a risk to that, because I could be out hundreds of dollars before I actually get this thing working. Now, it is a pretty good amp, but I don't really have a need for the amp myself, and there's no guarantee that I could sell it even after I got it working, because it is older. So I'm going to park this particular project right here, and we may come back to it a little later on, and we may not. So I think that's where we'll end this one. And it's never fun to come to the end of a video and have to say the equipment was not fixed, but there's no real way to do anything else in this situation, so that's where I'm going to leave it for now. Happy to get any comments from you about this, or a like, or a subscribe, and we'll look forward to seeing you on the next one. Thanks.